Assalamualaikum warahmatullahi wabarakatuh, and welcome to the fifth, I think, video lesson for physics. And this lesson, we are going to continue with the chapter, which is chapter 3, dynamics, which is all about forces. And we're going to talk about friction for this topic and this week. So let's start. Now, what is friction? Friction is a type of force, and this type of force usually opposes the motion of an object. An example of where you can encounter friction is when you slide a book on a table. So let me read this part. If we slide a book on a table with a small amount of force, it will only move a short distance. As it moves, it will start to slow down and stop. This is caused by an opposing force called friction. So friction is an opposing force. That means it is acting in a direction that is opposite to the motion of the object. In this example, you slide the book forward and there will be a force called friction that is acting backwards on the book. And friction is a type of force that because it opposes motion, it will usually slow down the object and eventually make the object stop. So we define friction as a force that acts in the opposite direction of movement. There are several types of friction, and we are going to look at them for these next few slides. The first type of friction is called the surface friction. And surface friction happens when two surfaces are in contact and are rubbing or sliding against each other. So let's say you have this surface, surface A, your left hand, and you have another surface, your right hand. These are examples of surfaces, and when you rub them together like this, you can feel the friction when you do this. So these are examples of two surfaces in contact with each other and sliding against each other, and that causes a type of friction that is called surface friction. So here are a few examples: sliding a book on a table, just like before, pushing a box on concrete floor, rubbing your hands together, and cars, especially the tires, moving on the road. So moving on the road. So these are examples of surface friction. How does this happen? So why is there friction when you rub two surfaces together? So consider the book sliding over a table. Even if the book's cover is smooth, it is not microscopically smooth. That means from our view, from our normal view, if we look at the book, we might think the surface is smooth, but actually when you zoom in down to the microscopic level or down to the atomic level, the surface is not actually smooth. So you can see in this picture here, the surface is actually rough when you really zoom in to the atomic level. And this is the same for the surface, even though from your view, from your eyes, and when you touch the table, it looks smooth, but when you really zoom in, there are valleys to the surface of the table, valleys and troughs to the surface of the table, and it's not a smooth straight line like what we imagine. So in fact, both surfaces still have a sort of roughness to them. As they slide against each other, the rough surfaces will catch onto each other. So you can imagine if the surfaces are rough, so they can get stuck to each other, and that's going to make it hard to slide past each other. And that is where friction comes from, because of these surfaces on the microscopic level, they are quite rough, and when you when you slide them past each other, they will catch, especially the peaks will catch each other, and they will make it harder to move. Generally, the rougher the surface, the greater the friction. So if you have a rougher surface, the friction is large. If you have a smooth surface, the friction is small. An example is, if you push a box on grass and compare that if you push a box on ice, so ice is a smooth surface, it's much more easier to push the box on ice because ice is a smooth surface and has less friction. If you push it on grass, then it's much harder because there's a lot of friction. Grass is a rougher surface. Here I have an animation that shows you what that looks like. So this is a simulation of what the surface looks like on the atomic level. So you have two books here, a chemistry book and a physics book. And you can see zoomed in, these are what the molecules or the atoms look like. So they're not a smooth line, they are peaks and valleys and troughs along the surface here. And when you slide them past each other like this, so let me do this for you. Okay, this will happen, right? Two things you notice will happen. One, here, as you can see, the temperature goes up. So when you slide things past each other, or when you rub things together, what do you get? So you normally get heat. Heat will be produced. So that is true for friction. If you rub things together, you will produce heat. So the kinetic energy in this case is converted into heat energy. So let's redo that again. So as you can see, as you rub them against each other, the atoms will gain heat energy. And you will actually, as you can expect, when you rub things together, the surface will become much more worn out. That's why we lose a bit of atom when we rub them together just now. And also the other thing that you might notice is that the atoms, as it gets hotter, the atoms vibrate even more. That's because when atoms get hotter, they get more energy, and therefore they can vibrate even more. So we will learn more about that in the next few chapters of physics. So not right now. The second type of friction is called air resistance. So air resistance, another name for air resistance is actually air friction. Okay, and we have encountered, or you have learned about air resistance before in the previous chapter. As you know, air resistance is caused when an object is moving against the air, and these are examples of air resistance. For example, when driving a car, we can feel the air pushing against the car, that is air resistance. When running, we feel friction on our skin and clothes, that is also air resistance. And air resistance is caused because and air resistance is caused by the air. So when you move through the air pushes against you and colliding against your body. So that is where resistance comes from. It is caused by air particles colliding against or on your body. The third type of friction is called water resistance, or you can call this water friction as well. Now, this type of friction, water resistance, is similar to air resistance, but in this case, we are dealing with water. Water resistance is caused when an object is moving against the water. For example, when you are walking in knee-deep water, you can feel water resisting against your movement, or when you are swimming upstream. So that means when you are swimming against the current, you can really feel the water pushing back against you, and that is also a type of water resistance. Why does water resistance happen? Similarly to air resistance, it's because of water particles colliding against your body and pushing against your body when you move through water. Now, friction is a force that opposes your motion. It acts in the direction opposite to where you are moving. And because of that, there are some positive effects of friction. So friction can be useful. So these are examples of situations where we need friction. In bicycle, motorcycles, and cars, we need friction in the brakes and tires to stop. So friction slows you down and causes you to stop, and you need friction if you want to stop, especially when you are braking. And friction is the force that enables you to stand. Without friction, that means everything is smooth. That means everything is slippery. When everything is slippery, it's very hard to stand, very hard to walk, run, or even hold things. So you need friction in order for you to be able to hold things and in order for you to walk. Friction is the force that pushes against you and is the force that resists motion. Just like friction can be useful, friction can also be not useful or hindering to whatever that we are doing. So these are examples of where we don't want friction to happen. Now, one of the negative effects of friction is that when, like I said, friction is, especially surface friction, is when things are rubbing against each other. And when things are rubbing against each other, the surface will tend to lose out. In other words, you are slowly removing the surface. And this is quite bad, especially in machineries where you want the parts to last as long as possible. But because of friction, the parts slowly will be worn out and therefore you have to replace them, and that is bad. Friction is unnecessary at times. If we don't have friction, our cars will move a lot faster. So especially in times where we want to move fast, we have to overcome friction. So in other words, we have to minimize friction if we want to move fast. An example where you minimize friction in order to move fast is the bullet train in Japan. So this type of train is very fast. It doesn't use tires or rails. Instead, it uses magnetic forces so that there will be a lot less friction. So I'll show you what this looks like. Right, so bullet trains look a bit like this. So this is a toy, and I'll show you later. I'll play the video soon. And this toy is an example of a bullet train. Basically, it is levitating. As you can see, it doesn't have any wheels. It is levitating using the power of magnets. So you can see there's a north pole here and a north pole there, south pole here, and then another south pole on the rail. And we will see what happens through this video, what that looks like, okay? So you can see it is actually floating, or in other words, it's levitating. And because it's floating or levitating, it can move quite fast. So friction can be quite hindering and it can be quite troublesome. Here are the ways in order to minimize friction. Number one, you add wheels or rollers. Number two, you make the surface smoother by putting lubricants, for example, oil, water, or soap. Number three, you smooth out the surface, you polish the surface in order for it to have less friction and can slide against whatever surface much more easier. Number four, use a layer of air. Instead of having the object sliding against the ground, you make sure it is levitating. And this can be seen in hovercrafts or, like the example before, the bullet train. Number five, you overcome air resistance or friction using streamlining. So streamlining means the body of moving objects have shapes that would encounter only a small amount of air resistance. Another name for streamlining is aerodynamics. Streamlining or aerodynamics, basically you just make sure you have a shape that will go through air quite quickly, or in other words, it can cut through air quite smoothly. These are some of the examples here in the picture. The circle here is quite streamlined, but it's not as streamlined as this shape here, this teardrop or aerofoil shape. The square here is not as streamlined because it doesn't cut air quite as smoothly as the sphere and the airfoil. So these are examples of streamlining in action. So you have learned about friction. You have learned about what friction is. It's a force that opposes motion and produces heating. And friction can be useful, especially if you want to stop and especially if you want to not move. And friction can be hindering if you want to move. And we also looked at the ways in order to minimize friction. Now we look at some calculations involving friction. So you remember before that when it comes to forces, we use the formula F is equal to ma. So you remember before, if you want to do calculations involving forces, this is the formula that we use. So F is equal to m times a. Force is equal to mass times acceleration. Okay, forgive me for my handwriting. Okay, well, just bear with it. Now, if this is true if you have one force. If you have more than one force acting on the object, now we have to modify this formula a bit. Instead of F is equal to ma, we have this. Now it becomes this. So Fr is equal to Ma. So what does Fr means? Fr means that means the resultant force. Okay. So in order to use this formula, especially if you have more than one force, and in the coming examples we will use this, you have to use the resultant force in this equation in order to find the acceleration. Right, so let's see what that looks like. Example 1. A girl pushes a box of mass 5 kilograms along a frictionless surface with a steady horizontal force of 10 newtons. So in this diagram here, what is the acceleration of the box? So to answer A, this is quite straightforward in the beginning. So force is equal to mass times acceleration. What is the force that is pushing on this box? The force is 10 newtons. What is the mass? The mass is 5 kilograms. And we have the acceleration. We have to find the acceleration. Now you rearrange this formula. When you rearrange this formula, the force will be on top. So that's 10. And the mass will be at the bottom. That's 5. So 10 divided by 5, that is 2 meters per second square. So don't forget to write down the formula, because writing down formulas is important in physics. So that is the acceleration when you are pushing this box with a force of 10 newtons on a frictionless surface. So let's just write that down here. The answer here. The answer is here is 10 meters per second square. Now let's answer question B. If the box is pushed across a rough surface, so this time for B, the surface changed. Now the surface is rough and the friction encountered is 4 newtons. What will be the acceleration of the box? So for this next question, we have friction because the surface is now rough. Before, the question is saying the surface is frictionless. Now the surface is rough. And we want to, and now the friction is 4 Newton. So we have to find the acceleration this time. Because we have another force acting on the object this time, therefore the acceleration will change. So we have to calculate that and what that looks like. So again, we use F is equal to ma. This is our main formula. Now, because we have two forces in this case, we have the pushing force of 10 newtons and we have a frictional force here, 4 newtons. Therefore, we have to find the resultant force of these two forces in order to use this formula. Now, the resultant force of these two forces, what is the resultant force? So you have 10 Newton to the right, 4 Newton to the left. So it's just a matter of 10 minus 4. So the resultant force is 10 minus 4, and the resultant force is 6 newtons to the right. Okay, so we could figure out what the resultant force is. So we figured out what the resultant force is. Now we come back to the formula, Fr is equal to ma. Fr is equal to 6. So this formula, so here, Fr is 6, the mass is still 5, and the acceleration is the thing that you want to find. Okay, I'm running out of space. So if we rearrange this formula, you get 6 divided by 5. And 6 divided by 5 is 1.2. So 6 divided by 5 is 1.2 meters per second according to my calculator. Meters per second square. And that's the answer. Okay? Example 2. A car has a mass of 1,000 kilograms and accelerating with a constant acceleration of 2 meters per second square. The driving force done by the engine is 4,000 newtons. Number 1, on the diagram above, draw and label all of the forces on the car as the car moves. So you have to draw the forces on the car. Let's do that. First, you have a forward force of 400 newtons. Let's do that. And we will call this the driving force, or yeah, so the driving force. Next, you have a second force, of course. And what is this force acting opposite to the driving force? And what is this force called? This force is called friction. Okay, that's not all. Now the car is on Earth, so you can expect another force. So there is a force downwards, and this force is called, what is it called? This is called gravitational force or gravity. In order to counteract the gravity or gravitational force, you need a force upwards. And what is this force called? It's a force upwards, and this force is called the normal force or the contact force or the reaction force. Okay, it's important to note that these two forces, the contact force and the gravitational force, are equal. That's why I'm writing down the equal sign on the two arrows to indicate that these two forces are equal to each other. So the contact force and the gravitational force are equal to each other, and they cancel out, and we can just ignore them. The driving force is bigger than the friction, of course. That's why I drew the arrows longer for the driving force, and the friction has a shorter arrow. So that is done for question number 1. For question number 2, what is the amount of friction that the tires have in order to have? Oh yeah, by the way, where does the contact force come from? The contact force comes from the contact because the car is in contact with the ground or the road, and the road, therefore, road pushes against the car, and that force from the road is called the contact force. Number 2, what is the amount of friction that the tires have in order to obtain a constant acceleration of 2 meters per second square? Now we have to figure out what is the frictional force. Let's ignore these two because these two are no longer important for our calculation, and just focus on the friction and the driving force. Okay? Now we have two forces here, so that means we use this equation here. The resultant force is equal to mass times acceleration. Okay. What is the mass? The mass is 1000. What is the acceleration? The acceleration we want in this case is 2. So what should be the resultant force in order for us to get an acceleration of 2? Now, we cannot find the resultant force because even though we know the driving force is 4,000 Newton, we don't know what the size of the friction is. So for the time being, we can use algebra here to say, D, in order to get the resultant force, the driving force, D, minus the friction force. Let's say the friction force is let's use X for the friction force, okay? Right, so D minus X. So that means if we want to get the friction, if we want to get the resultant force, we need to have D minus X, so driving force minus the friction. Now we know what the driving force is. The driving force is 4,000. Let's just put that value in. And friction is the X, and that is what we want to find. 1000, mass is 1000 times 2. And the formula becomes this. And because the formula looks like this, we can solve for X. We can find the friction. So 4000 cannot be deducted by X because we don't know what X is. But we can simplify 1000 times 2, that's 2000. And then we can move the numbers around, so we can move the 4000 to the right side, and we will get 2000 minus 4000. Okay, so we are moving 4000 to the right. Now the top 4000 becomes minus 4000. Let's continue on. I'll continue on the left side here. So minus X, I'll continue on the left side because I don't have space on the right side. That minus X, that's still the same. 2000 minus 4000, that is minus 2000. Okay, So minus x is equal to minus 2000. We can cancel out the minuses. We can simplify that and cancel out the minuses. And then you are left with 2000. And that's the answer. Okay, x is equal to 2000 newtons. Okay? So, to summarize, friction is a force that opposes motion of moving objects. And also I would like to add here, and it produces heat. Okay, so that's another characteristic of friction, produces heat. Okay, we looked at the positive effects of friction. So friction can be useful, especially in braking and in standing, walking, and holding. Friction can have negative effects. So friction can give us disadvantages. Friction can cause wear and tear of moving parts in machine, and friction can slow us down. How do we minimize friction? If you want to move faster, or if you want to reduce wear and tear, we add wheels, add lubricants, use smooth surfaces, use a layer of air, or use streamlining. So that concludes our topic on, or our lesson on friction. I'll stop there for today and I'll continue again next week. The next topic is all about braking distance and stopping distance. So until then, stay safe. Assalamualaikum warahmatullahi wabarakatuh. Thank you for watching.